Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we will be discussing another method of optimization, that is the random search method, right? So in this video lecture, we will be learning about the random search optimization method. What is this random search optimization method? Basically, it is another form of technique by which we find out the minimum value of the function. Now, as the name suggests, it's a random search method. All right. So this means that what we do is we select certain points randomly, and through these random points, right, we generate large number of random points, and through these random points, we evaluate the function, right? And based upon the values that we get from this random point, whatever be the function value that we get, the smallest value we consider as the minimum point. All right, so randomly we select the points in between our boundary condition, and then we find out which of the value is giving the minimum minimum output we are getting, and that is what we consider as our minimum point. Okay, now talking about the algorithm, basically what I have done is I have tried to simplify the algorithm of this random search method, right? In various books you will see a lot of complex variables and mentioning of a lot of complex variables and equations. So what I have done is I have tried to simplify as much as possible. All right, so let us look into the algorithm. The first step in this random search method is, first of all, to define the search space. All right, based upon the function value and based upon the constraints that are there attached to the function, we define our search space. That is, we define the extreme points and of the extreme points of the search space, and then what we do is we set the number of iteration. So the step number two will be setting up the number of iterations, right? Once we have defined our search space, we will define how many number of iteration we need to do. Why? Because you see, we have a search space, and in this search space, a number of points can be defined, right? So it is very important based upon our demand for the accuracy, how many interval of points we need to choose and how many iterations we need to do. Once we have decided the number of iterations, we generate the random solution. By choosing the random points, we generate the random solution, and then we evaluate the objective function, right? Based upon the random solutions that we get, we assess the performance. What does this mean? Let's say we have chosen point, one point. Likewise, we have chosen second point, third point, and likewise n point. So whatever point that we are choosing, is the previous results was minimum than the result that we are getting right now, or the previous was the minimum point. So based upon the values of the function that we are getting, we update our results, right? And we keep on repeating the process till we are satisfied with the outcome. And at the end of the iterations, we basically we do is we point out the best solution that we get. Okay, so let us understand this algorithm through a numerical example. So the first question that we are going to do is, the question is minimize the function fx, which is equals to x minus 3 whole square, and our search space is between 0 to 10, and the number of iteration that we need to do is 5. All right, so this is the question. Let's solve the question. Okay, so let us do the solution. That is the solution. All right, so if you see the first step was to define the search space and set the number of iteration. And if you see in the question, we have been already given the search space, and we have been given the number of iteration. So this means that our step 1 and step 2 is more or less being covered, right? So our search space is between 0 to 10, and the number of iteration that we are going to do is 5. All right, so now what is the step number 3? Let us see what is the step number 3. Step number 3 is to generate random solution. How do we generate the random solution? By picking up the random point in between the search space. All right. So you see, we have to do 5 iterations, right? And this is my search space. That is the value should be between 0 to 10. All right. So let me take some random value. Let me take the random value of x. These value let me take as 2.5, 7.8. I'm taking the value randomly. 3.1, 4.5, and 1.2. Right? 1, 2, 3, 4, 5. 5 iterations, 5 values I have chosen. You can choose differently, but make sure the value lies between 0 to 10. All right. So now I have chosen the random values. Now what I will do is I will evaluate. If you see, I will evaluate the objective functions. All right. I will evaluate the objective function. All right. So for function f 2.5, for 2.5 value, the equation is x minus 3 whole square. So what I will do is 2.5 minus 3 whole square. So the value of this we are getting is 0.25. All right. Likewise, my next value is at x equals to 7.8. Again, 7.8 minus 3 whole square. So the value will be 23.04. Again, f 3.1. F 3.1, this is 3.1 minus 3 whole square. The value you will get is 0.01. Then f 4.5, at f 4.5, 4.5 minus 3 whole square. So the value that I will be getting is 2.25. Then I have f 1.2, at 1.2 minus 3 whole square. The value that I will be getting is 3.24. All right. So through these random values, I have generated the values, right? The function values. Now, what I have to do is keep a track of the best solution and its performance. So basically what I'm doing is I'm looking at the solutions, right? I'm just looking into the various solutions, right? And then from here, I have to see which value is getting the minimum, right? So here I can see, if you see at f 3.1, I'm getting a minimum value of 0.01. So the best value that I'm getting is at x equals to 3.1, my fx value is 0.01, right? So my output for best solution is at x equals to 3.1, my fx is 0.01, right? So this is the step-by-step solution for the random search method, right? It's a very simple question that I have taken. So I hope you get the gist how the random search method works, right? So based upon the function value and based upon I have since in the question I was already given the search space and the number of iterations, so I have worked according to the parameters that are given, right? Now, one thing you may observe, the minimum value that I'm getting is based upon the search space, the random values that I have taken, right? So it may happen that you may take some other value, and from that you may get even lower value than what I'm getting in the question, right? So in this random value, this random search method, it is very important how you have defined or what random values you have taken. So that is why in between your search space, in between 0 to 10, you can go for 0.1, in fact 0.01, 0.00001, depending upon how accurate and how much iteration you are setting. If you have a lot of time, if you have like if you want to go for a if you want in between the search space, if you want to look into the each and every point, if you want as accurate data as possible, you can look into finer points, right? Like I have just chosen point randomly. You can go for 1, 2, 3, 4, 5, or you can in fact improve your number of iteration from 5 to, let's say, 5,000, right? If you go for a number of iteration 5,000, then you can choose lot of near points, right? Lot of near points, or very minute points randomly in between the search space of 0 to 10, right? So that is how the this random search method optimization works, right? It depends upon the points you are choosing in between the search space and the number of iteration you are willing to go. All right. Now let us do another question. Okay, just this was a very simple question, just for the sake of understanding how this random search method of optimization works. Now let us take another question. Okay, let me take another question. Right, question is, let's say I have to minimize the function f x1 comma x2. Now I have two variables. The equation is x1 minus 2 whole square plus x2 plus 3 whole square, and my search space x1 comma x2 should be within minus 5 comma 5, right? My search space should be between minus 5 and 5. And let me just say that number of iteration that need to be done should be not more than 10. The number of iteration should be equal to 10, neither less, neither more. Got it? So this is the question. Now we have two variables. This is the equation. My search space should be between minus 5 to 5, and the number of iteration that I should do is 10. Correct? So now let's solve the question. Let us solve the question. Let us do the solution. All right. So again, step number one is already covered. My search space is already defined between minus 5 to 5. And second is the number of iteration that I need to do is already defined as 10. All right. Now what I have to do? I have to, what I have to do? The step number three will be, I have to choose the random points in between my search space and find out the function values. All right. So let me just choose the values. Okay. So we have the x1 value and we have the x2 value. All right. Let me just take x1 value as minus 4.5 and x2 value as 4.2. All right. Now, if I put the value in equation that is given to me, function value, so the value that I will get is 82.09. All right, 82.09. Now I'll choose another value. Let me choose x1 as minus 1.1 and x2 as minus 1.5. So what I'm doing is I'm jumping from one point to another, right? And by taking this value, the value that I'm getting is 20.66. All right. Now I'll again randomly jump to some another value, right? Let's say I randomly jump to a value of x1 as 2.8 and x2 as minus 2.9, right? This is a random jump, right? Now if I put these look into the functional value, I will get 0.02, right? Which is my new minimum so far. All right. Then again, I will jump to a random value. Let me say I am jumping to point 3, minus 3 and minus 4.0. Then if I do so, the function value will be 62. All right. Again, I'm jumping to another point of 3.2 and minus 2.7. I'm randomly jumping, right? That is what this is. I'm randomly jumping in between my search space, right? Mind it, I'm randomly jumping in between my search space of minus 5 to 5. I'm not exceeding my search space. I'm randomly jumping in between my search space. All right. So if you see, I am still 0.02 is my minimum value so far. Now let me jump to point 0, comma 0, 0, comma 0. Then the functional value that I will get is 29.00, right? Let me see how many iteration I have done. I have done iteration. This is my iteration number 1, 2, 3, 4, 5. This is my sixth iteration. Now I'll go for seventh. I'll mark all. 7, 8, 9, and 10. Okay, right. Now, now my seventh iteration. Let me jump to point 4 and minus 4. If I do so, I'll get a minimum value of 5. Then I again take a random jump to point 1.9 and minus 3.1, and I will see now my new function value, new minimum value, or the new best value is 0.01, which is minimum than the previous value that I have got so far, right? So as the step says, I have to update my best solution, right? I'm just keeping a track of the value that I am getting, right? I'm keeping a track of the best solution, and I'm updating my best solution, and I'm going to continue repeating the same to the set number of iterations, uh, and then after the number of iteration, I will give the best solution as per my random jump. All right. Now after this, I will take another point, let's say minus 5 and 3. Now the point that the function value that I get is 85. Then again, the last jump that I will do is at point 2.1 for x1 and minus 2.8 for x2. So the value that I will get is 0.05. All right. So if you see, the minimum value that I have got through my jump is 0.01, right? So what I'll do is I will report my solution, right? My best solution, my best solution from my jumps that I got is at x1 equals to minus 1.9 and x2 equals to minus 3.1, and the functional minimum functional value that I got through this jump is 0.01, right? Since the number of iteration that I was asked to do was 10. So during these 10, the based upon the number of jumps that I have done, this is my best solution, right? This is my best solution, and this is my stopping criteria, right? This is my stopping criteria, right? I have fulfilled my stopping criteria that at n equal to 10, the value of x1 comma x2 I have got is 1.9 comma minus 3.1, and fx value is 0.01. All right. So I hope through this question the gist of random search method of optimization is much more clear, right? So that is why it is called as random jump method, right? You randomly jump in between the search space, and based upon the number of iteration that you have set, you do the desired number of iteration. All right. Now let us do another question. Okay. Let us do another question. So let us do another question. Now the question is that our function value is x1 comma x2, and the equation is x1 square plus x2 minus 11 whole square plus x1 plus x2 square minus 7 whole square. And the constraints that are given to us is that the equation g1 x equals to 26 minus x1 minus 5 whole square minus x2 square should be greater or equal to 0. G2x equals to 20 minus 4x1 minus x2 should be greater or equal to 0. And the third constraint, this is constraint number 1, this is constraint number 2, and constraint number 3 is x1 comma x2 should be greater or equal to 0, right? So these are the constraint that is given to us. correct? So now what we have to do is we have to solve it. All right. So here, if you see, like the step number one, our step number one is to find out the search space, is to find out the search space, right? So for this, what you have to do is you have to first of all choose the value of x1 and x2 such that uh, that the all these criterias should be fulfilled. Now here if you see the value of x1, the value of x1 and x2 should be greater or equal to 0, right? Should be greater or equal to 0. Now if I put the value 0 in here and here, what I'll get? I'll get this to be 26, and here also I'll get 20, right? Likewise likewise if I put x equals to 1, I will again get the positive value. X equals to 2, I'll again get the positive value. X equal to 3, I'll again get the positive value, and likewise. So what through this you have to find out the search space for yourself, right? So I have already done the calculation, so I'll just without wasting time, I'll just take a random search space of x1 search space I will take as 0, 5, and x2 search space I will take as 0, 5. Right now, you can also try for x1 equals to x1 and x2 equals to. Now, up till this range, you will get a positive value, right? You can also try some other different values, and you can see if these constraints are being fulfilled or not, right? But for me, I have found out to be these to be fulfilling my desired criteria. Like criteria number 3 is being fulfilled, and constraint number 1 and 2 are also being fulfilled. Correct. So now I have done the first step. That is, I have defined my search space. Now I will go for step number 2. Right. Step number two. Step number two is to define the number of iterations. Uh, just to save some time, I will take the number of iteration to be 4, right? That is, I will only do the 4 iterations. Then the step 3, I'll go for step number 3. Let me just check what is step number 3. What is my step number 3? Step number 3 is to generate random solutions, right? This means now I have to jump to the random points, right? I have to jump into the random point in between my search space. Again, just like previously, this is my x1, this is my x2. I have to keep on fulfilling my constraints g1, right? G1x and g2x, right? And uh, then I have my function value f x1 comma x2. All right. So let me jump in between my search space. My for x1, my search space is 0 to 5, x2 is 0 to 5. So let me take random values, right? Let me take random values. X1 will be 2.5, x2 will be 3. Okay, so through this, my G1 value will come out to be 22.25, and G2 value will come out to be 9.0, and my function value will come out to be 0.25. Right, I hope you are getting this, how I am getting. So x1 value I have taken 2.5, x1 value 2.5, x2 value as 3. I am putting the values here in this equation, and this equation, right? And of course, since the values are greater than 0, like the all the three constraints are being fulfilled, right? So my f x1 x2 is 0.25. My second iteration I'll again jump to some random values. Let's say I'm jumping to 1.0 here, and 4.0 here, and through this my g1 value will come out to be 14.0, my g2 value will come out to be 12.0, and fx1 is 4, right? So far this is my minimum value, right? Then my third third iteration, the third point where I will be jumping will be 4.5 and 2.5. 4.5 and 2.5. So my G1 value will come out to be 4.25, and G2 value 2.5, and the minimum value is 0.16. Now this is my new minimum, right? This is my new minimum. Then my fourth and last iteration. So again, jump to a random value of 5 for x1 and 0 for x2. And my g1 value will be 1.0 and g2 value will be 0.0, which again I must say I am fulfilling the constraint equal to 0. Okay. So here the fx is 14.0, right? So my first minimum till for certain iteration was 0.25. Now I have updated my iteration, updated my minima to be 0.16. So based upon my random jumping, the best solution that I have got is for x1 comma x2 is 4.5 comma 2.5, correct? 4.5, 2.5, and the minimum value f x1 comma x2 is 0.16. This is my best or the optimized minimum solution. All right. So this is how the random search method of optimization is being carried out. All right. So, I must tell you this, that these results I got is based upon how I am jumping. Right. It may happen that you may have randomly jumped to a different point, and your minima might be much lesser than mine minima. Right. So you may get more optimized solution than me. It is possible, but based upon my jumping and based upon the constraint that I had, that is that the number of iteration that I had set equal to 4, you may set n equals to 500, right? And then the number of jumps that you may do might be higher, right? Like if you get 4.5 to 2.5, then you may jump nearby these areas, right? That is up to you. You are doing a random jumping based upon your convenience, right? And the number of iterations that you have chosen, right? So it is possible, 100% possible that the minima that you will get can be lesser than what I had got, right? But this is my solution, right? So this is how the random search method of optimization is being carried out, right? I have tried to explain this random search method in the most simplest way possible. I hope the this method of optimization is clear to you. If you have any doubt, you can ask in the comment section, or you can share your views about this lecture in the comment section. Thank you for watching. Have a nice day.